In this video, we're going to talk about how to determine the reaction order graphically using the integrated rate law. So we talked about the integrated rate law that connects concentration and time, and that there are different forms based on the different reaction orders. And we said that those forms could be linearized so that they follow the pattern of y equals mx plus b. So we can use those linear forms to check whether or not our data make a line with a particular integrated rate law. So if we can, for example, plot the concentration versus time, and if that plot shown over here is linear, then we know that the reaction would be zero order. If that's not linear, then the concentration versus time data are curved in some way, but we don't know what kind of curve. So we can next plot the natural log of concentration versus time and see if that's a line. And if it is a line, then we know the reaction is first order. And if it's still not a line, then we can try our second order rate law and plot 1 over the concentration versus the time and see if that's a line. So we basically test each of our most common rate laws in order to see which one fits best. So what does it look like if you plot some data and the rate law isn't right? So example, in the first group, we have that concentration versus time is linear, and it makes a negative slope because the reactant is being consumed. But if we try to use the wrong rate law, the natural log or the 1 over concentration, we see that we get a curve. So you can see those here. We see that we get curves instead of lines. And so the data don't make a line, and therefore that's not the appropriate integrated rate law. In the second case, so we got the three graphs together. We see that we plot concentration versus time, it makes a curve. Natural log versus time makes a line, and 1 over concentration also makes a curve. So we can see that the only one that makes a line is the natural log versus time, which means that this reaction must be first order. And so we have data for yet a different reaction at the bottom, and we can see that if we plot concentration versus time, it makes a curve. If you had a first order curve and a second order curve together, you could see that they look a little bit different, but if they're separate from each other, it's hard to tell. So we plot natural log versus time and 1 over concentration versus time, and we see that, again, only the one that matches 1 over concentration versus time makes a line. So the key is to look for which data sort of match the rate law. So try this one. Some concentration versus time data are plotted. What is the reaction order? Okay, so here we see that the natural log versus time makes a curve, and the inverse 1 over concentration versus time makes a line. So therefore, this reaction must be second order because it's the second order rate law that makes a line.